Standard deviation measures how spread out a set of measurements is and tells you how much individual values typically differ from the average. So, a small standard deviation means measurements are close together, and a large standard deviation means they are more spread out. Think of taking the same chemistry measurement many times, like the length of a piece of glassware, and then finding the average of those measurements. Standard deviation shows how far the measurements usually are from that average. To get it, you find the differences between each measurement and the average, square those differences so negatives do not cancel positives, average those squared differences, and then take the square root to return to the original units. This process gives a single number that represents the typical size of random variations in repeated measurements, which chemists use to report uncertainty. It helps you know whether differences between results matter or are just random noise. Students often confuse standard deviation with the range, thinking the spread is just the highest minus the lowest value, which ignores how most points cluster. Remember that standard deviation uses all data points and weights typical variation more than extremes. Another common mistake is treating standard deviation as a fixed error instead of random uncertainty, so do not add it directly to a measurement as if it were a bias. Instead, use it to express uncertainty around the average. A final misconception is forgetting to use the correct divisor for sample versus population calculations, so choose the version that matches whether your data represent the whole population or a sample from a larger set. For more videos and resources on standard deviation and reporting uncertainty, check out www.gumballdegree.com.